Yo, what's up, guys? Today we'll be talking about IVT, which is a very important concept in early AB calculus or in any type of calculus. And so you might be wondering to yourself, what is IVT? Well, IVT is just an acronym for Intermediate Value Theorem. You might be wondering, well, what is this? Why is it important? Why is it relevant to my life? First of all, we have to realize what this theorem states. So let's say you had a graph. Let's say you had A on the x-axis and then B as well. And let's say you had like a curve. I don't know if this is a function. But let's say you had f of A, and then let's say you had f of B. According to the theorem, if there exists a point where f of C, where an imaginary point of f of C exists between A and B, therefore a value C must exist. And so I'm going to dumb it down for you. Let's say you had t equals 1. Let's say you were filling up your gas tank, right? Let's say this is like your gas tank. And then at t equals 1 minute, you had 10 gallons of gas. So like t equals 1, you will have like this much. And then at t equals 2, you will have 50 gallons. So let's say this is t equals 2, then you'll have this much. So from t equals 1, you will have 10 gallons of gas. And then at t equals 2 minutes, you will have 50 gallons of gas. What this theorem is stating that at some point between 2 and 1 minute, there has to be a point where your gas tank at some point was 30 gallons. And this might seem like logical sense. You can't just skip over 10 to 50 gallons without having 30 gallons of gas, or else that would break the laws of physics. You can't just do that. So what this theorem is stating is that if f of c exists between f of a and f of b, therefore there must be a value c that exists between a and b. And what do I mean by that? Well, let's take a look at this equation. Let's say you had f of x, which is equal to x to the third plus 2x squared plus 5x minus 8. And then let's say your domain was 1. Oh, sorry, not 1. 0 to 1. And my fault. That was 6. I don't know why I changed it to an 8. I know I said 8, but that's supposed to be a 6. From the domain of 0 to 1. What you would do to find out, and then let's just set up the function f of x is equal to 0. So in order to see if we have a solution between the domain, we have to plug the numbers in. So f of 0 is just negative 6. F of 1 is just equal to 1 plus 2 plus 5 minus 6. 1 plus 2 is 3, plus 5 is 8, minus 6 is equal to 2. And this is where the big part comes in. Negative 6 and 2 are between the point of 0. So we can write this as f of 0, 0, f of 1. Reason why that is because negative 6 is less than 0, which is less than 2. Therefore, there exists a point where there has to be some sort of value c. So if you were to have f of c, which is equal to 0, and you might be wondering to yourself, well, how can you prove this? Well, I know on the AP test, I don't think this will be on your calculator section. However, let's say you were to graph this. So this is your graph, right? And we're saying between 0 to 1, you would have a value which is equal to 0. What is that? That value is between 0 and 1. So according, because I'm using decimals, right? Point 82037 would be your value C. That would equal this function equal to 0. So essentially saying this theorem proves that there's an f of C which is equal to 0. Just some sort of thing that is equal to 0. And we just proved it using the graph of decimals. That's essentially what this whole theorem is saying. Now let's say you were trying to prove there's a value C which is equal to 5. And then let's just say you have the function f of x is equal to x squared plus 5. And then between the domain of 2 and 3. You just have to plug the numbers in. So f of 2 is equal to 4 plus 5, which is equal to 9. And then f of 3 is equal to 9 plus 5, which is 14. From here, you can see that since 5 is not between these numbers, because 5 would be less than f of 2, which is less than f of 3, therefore, no value exists where f of c is equal to 5. That's essentially what this whole theorem is saying. Now let's take a look at another example. Let's say you had to prove that f of c, there's a value c which is equal to 1. Let's say you have the function f of x is equals to x to the 5th plus 6x minus 5 between the domains of 0 and 1. Again, you would just plug the numbers in. F of 0 is negative 5. Then f of 1 is equal to 1 plus 6 minus 5. 1 plus 6 is 7 minus 5, which is 2. And since f of 0 is less than 1, which is less than f of 1, because f of 0 is negative 5, which is less than 1, which is less than 2. Therefore, there exists a value c where f of c is equal to 1, or f of x is equal to 1. That's essentially saying the same thing. And so essentially this is just like a simplified version of IVT. This is just how I like to look at it. And again, we're going to go back to the gas reference. It's essentially just saying that it's like logically saying, it's like saying if you had like 10 chips and you ate 5 of them, at some point you still had 7 chips left in the bag. So essentially that's just my way of seeing it. Thank you for watching. This has been intermediate value theorem. Of course, if you didn't understand, I could always go into the topic deeper, but this is just an oversimplified version of what IVT is. It's just like basically a quick way of introducing you to IVT. So hopefully y'all like the video, like, subscribe, share, and thank you.